G'day, good morning, good evening. Thank you for listening. This is a medical show. I respect the law and I hope you do too. The information today is provided for scientific and educational purposes. The info is fact-checked and any links or websites will be put in the description below. And if you're rewatching this back, I haven't quite worked out what today's title is yet. It could be continuing on with the soil fertility and fertilizers course that I did, or it could be some open topics. So I'll wait to see what happens from chat. So if you're watching this back, you might want to fast forward until you see some slides, like when the screen changes, and that's a bit of an indication on when it's officially started. So I'll give it until 2 minutes, which is another 55 seconds. Wait for hopefully someone to arrive and we can start the show. That's right, it was a bit slow last week. There was no one at the start. I remember that. Oh well. I do this because I'm quite experienced and up to date with study in the plant science, soil science, and microbiology. So I like to share information because there's a lot of, how could you put it, bro science or just wrong or misleading information. It's good to know the whole story, not just parts of the story. Then you can make good evaluations for yourself. Nearly up to 2 minutes now. Oh well. No one's arrived. Looks like it's going to be getting in. I was going to ask which. All right, I'll ask if someone is listening. So because there's no real questions and discussion topics, I'm going to go through this course again, the Soil Fertility and Fertilizers class, written in 2022 from, I can't remember which university it was. Professor Chakraborty taught it though. He's a rad teacher. And there's the 12 weeks. And I've done week 1 and 2. So I can go to week 3 and 4, which as you can see, it's phosphorus and potassium. Or the next week was the other primary nutrients, the calcium, magnesium, and sulfur. And then micronutrients, the other 12, I think it is, that are in the micronutrients. Or I can go straight on to soil testing and soil fertility evaluation methods, which I kind of prefer, because these ones are a bit, if you want to get real technical, you can, because different magnesium plays roles with phosphorus and just different things like that. It's very technical, of course. This is one of the best courses I've done, I think, so far to date. Or we can get up to evaluation and the fun stuff like the soil health and quality and organic manures, which I prefer. I love the organics, so it's good to see that. Bio-fertilizers, always rad. But anyway, if you're listening, tell me, what do you think? I reckon soil testing and fertility. Or if you really want, I'll continue it on, go week 3, week 4, week 5. Let's see what chat reckons. All right. Well, it seems like I'm the only one watching. It says it's only one person. So I'll just continue with soil health. That's what I want to do. Wow, so that's that, eh? So here's the slides for today. Not a great deal. It's so important. No, that's the wrong class. That was a post-harvest productions in agriculture. Was this class? Wonder why that's put in here. Just been through it. Titratable acidity, instead of microbes. All right. It's not really related to soil health. Recall. Soil fertility is the potential of the earth or inherent capacity of the soil to supply plant nutrients in quantity, forms, and proportion required for the growth and development of the crop. And productivity is the yield, and fertility is the factors that make up the soil or your substrate. Lieberg's law of the minimum, already gone through that, Lieberg's law of the minimum, but if we haven't, it's whatever is the lowest factor out of the 17 essential elements of the plant can only do as good as that element. So here the amount of nitrogen available is 40%, so it can only ever do 40% of its growth and requirements. There he is, Lieberg. Oh, here's a good example. See how whatever's the lowest, it's as good as that factor. So I can't ever go any higher up because it's only as good as what the lowest factor is. Or diminishing returns, no. Fertility evaluation. Several techniques are commonly employed to assess the fertility status of soil. 5 of them here. Nutrient deficiency symptoms of plants, plant analysis and tissue testing, methods involving the growing of higher plants and microorganisms, soil chemical analysis, and isotropic dilution method. Let's have a look at a few of them. So here's some hidden hunger. There he is, Chakravorty. I'll just read it. Hidden hunger is a term used to describe a plant that shows no obvious symptoms of deficiency, yet the nutrient content is not sufficient to give a profitable yield, or the yield that you should expect. So it's pretty cool for it to be in that rate. So you can see down here on the x-axis is increasing the fertilizer, and on the y is increasing the yield. So your top yield's right up here. So how do you get that top yield? Well, down here you're going to get symptoms of deficiency because, well, that's how it goes. And then you're going to fix those symptoms, and then it's going to hopefully be above hidden hunger. But how do you know if it's in hidden hunger? Because the yield is hurt a little bit. So if you're normally getting the yield that you'd like, you could possibly be in hidden hunger. Nutrient deficiency symptoms. Detecting hidden hunger in crops is a problem as yield goals rise and higher profits are sought. In this zone, with no symptoms to guide us, one must turn more diagnostic chemistry to evaluate these needs more accurately. So testing plants and soil help plan or modify the plant nutrients program to avoid the problem in future crops. That's why organics is the go, because you don't have to do as much analysis because you're feeding the soil by putting manures and crop residue, green manure, all that sort of stuff on top, which breaks down and slowly gives you the chemistry it requires. So organic manure is very good in the long run. Plant analysis and tissue testing. Well, tissue testing is a bit hard because you need the equipment to do it. So I'm not really going to go into that, but it's pretty cool though. You just need the NPK test kits to be, once you get those, you're pretty right. Because you just get a little, what's that little thing called? The chopper, like a paper hole cutter, and you cut a leaf with one sample of that, and that's enough. Or this way, they reckon squeeze the plant tissue with pliers and do it that way. Or you can do plant analysis. So both assimilated and unassimilated elements are measured. Plants grown in soil is acid, and the different nutrient elements are estimated. There is a functional relationship between the content of a plant's nutrient and the growth or yield of a plant. So that's pretty interesting, isn't it? In contrast, the soil analysis, tissue analysis reflects nutrient uptake condition of the soil or your substrate. That's how to do the test. No, I'm not going to go into the tissue test because not many people are going to do that, but here's on the screen if you really want to know. Concentration of nutrients in the tissue. So you plot them afterwards and you see what's going on. Using plant analysis as a diagnostic tool. Well, the relationship between nutrient content and the nutrient availability in the soil generally follows an asymptomatic curve. This means above the critical nutrient level in the plant, only small changes in plant nutrient content may occur, despite marked increases in the nutrient availability in the soil. This is another way of using the DRIS system. What's to do with that measuring? No, that's plotting it. Crop logging. What's this crop logging in reference to? If crop logging is a graphical representation of the process of the crop containing a series of chemical and physical measurements. These measurements might include the maximum yield, a critical nutrient concentration approach. All right, looking for deficiencies. During the growing season, plant tissue is sampled every 35 days and analysed for nitrogen, sugar, moisture, and weight of the tissue. So I wasn't going to go into the tissue taking, but there's an example of the plot you might put down. Pretty cool. Very cool, actually. Just one page, and it tells you so much information. You might take it, well, it's every 35 days, so the lines might represent every 35 days. So you can see that's over a whole crop cycle. Cool as. Methods involving growing higher plants and microorganisms. We should see if anyone's rocked up yet. Oh, Sunshine has. What do you know? G'day, Sunshine. RB. Sunshine RB says, I heard something about BT application in food agriculture causing leaky gut. Got anything on this? BT, I think you're talking about Bacillus thuringiensis. Is that right? And if it is, the answer is no. And causing leaky gut, I don't think that's in humans. And if it is, that's probably a bacterial infection. Okay, it is Bacillus thuringiensis. It is a chance that that bacteria has got a virus. I know that sounds weird, but virus can inhabit everything and give infections. Even bacteria get infections. They get fungal infections too. So there's a chance that possibly that strain, if it's localized in one area, I'd suggest that it's a infected Bacillus thuringiensis. Oh, hang on. They said causes it make insects' stomachs explode. Oh, insects, yeah. It causes damage to us also. No, well, it's pretty safe for humans to use from what because I use it. And yeah, it affects the microbes. It's, how does it actually work? Let's have a look. So we'll just pause that for a bit. And the question is, makes the insects' stomachs explode. Well, explode, no, actually, because explode is where fragments and stuff go everywhere. So I don't believe that one. But let's just have a look to see how it actually does work. Oh, underneath, just some bro science he saw on Instagram. Yep, see? Because is it the one that gives white masculine disease? No, that's muscadine disease, sorry. Here we go. This is a very trusted site. Now, BT occurs naturally in the gut of caterpillars. in various types of moths and butterflies. Okay, it's mode of operation now. Subspecies, genetics, no. Oh, here we go. On sporulation, so when it forms its spores, crystal, okay, let's go into that. BT has specific activities against different things. BT serves as an important reservoir for toxins production in biological insecticides and insect-resistant genetic modified crops. When insects ingest toxin crystals, their alkaline digestive tracts denature the insoluble crystals, making them soluble and thus amenable to being cut with proteases found in the insect's gut, which liberate the toxin from the crystal. The crytoxin is then inserted into the insect gut membrane, paralyzing the digestive tract and forming a pore. The insect stops eating and starves to death. Live BT bacteria may also colonize the insect, which can contribute to death. Death occurs within a few hours or weeks. The midgut bacteria of susceptible larvae may be required for BT activity. So there you go. It just gets in and infects it with the cry crystals, and it slowly shuts off its insect gut cell membranes. Hope that helped, mate. Just some bro science, yes. Hello, Lene, how are you? Got 3 people watching now. Wow. Yeah, just reply back, Sunshine, if that didn't help. But BT's rad. BT. Well, I had cabbage white moth. Got one application of BT with my IPM spray, got rid of it. No more problems. But I also used a few others. I put a few extra for my IPM spray, did the Bacillus polymix up, and did some Bavaria bassiana. What's that one? It starts with Bacillus subtilis was there. Got thrown in. It's always good. Trichoderma. Trichoderma hazarium. That's another one. But all right, back to this. Sounds like a lot of glyphosate. Yeah, glyphosate's not good. All right, I'll get back to sharing the screen, what we're up to. Methods involved in growing higher plants and microbes. They're just the different techniques to do it. Look at that method for available by Aspergillus niger. You can get by working with Aspergillus, you can get aspergillosis in humans, a lung problem. Soil chemical analysis is another way to test your soil potential. So a chemical method for estimating the nutrient supply capacity of the soil. I'm not going to really go into that because they're hard to get. Unless you can want to pay, I think it's $85 or something from your local government to get it tested. That's per sample, and to do an area 1 hectare, you're supposed to take 20 samples. So yeah, I tried to get the nutrients for this analysis to be done on the field, and struggled and gave up. But that's another way. Purpose of soil analysis is 3 things: to determine the level of availability of nutrients, to predict the fertility of the soil or substrate, to evaluate the status of each nutrient element. Benefits of soil testing. Soil testing encourages plant growth by providing the best fertilizer recommendation. It diagnoses, because you can get toxicity as well as deficiency. So you can get the underside and the overside. So it's just hard to know, because 95% of the plant gets its nutrient requirements from the atmosphere with CH and O. making up those three elements. And then it comes down to nitrogen, which is 1.5%. So it's not much. Benefits of soil testing: it diagnoses whether there is little to or too much nutrient. Soil testing provides environmental qualities. It also saves money that might otherwise be spent. It also tells you if the area that you're using is fertile enough to where it's going to be good for the next crop. For instance, if the nitrogen is extremely low, or more so the ammonium is really low, you'll know, oh, well, unless I put ammonium in, there's probably no chance that it's going to be there for the next crop. But if you've got a high amount, you'll know there is a chance. When and how to take the sample of the soil before planting. Eddie figured the field after harvesting. And you want to, so when and how to take a soil sample is before the application of any organic or chemical fertilizer, and 3 months after application of any organic or chemical fertilizer. Do not take a soil sample from the following areas: grazing areas, under a tree, or garbage areas. Why? Well, grazing areas, it's going to be a false indication because it's going to only be wherever the poo is. Under a tree is more fertile than out of under a tree. You'll see if you look out in paddocks, it's always green, the substrate, because all the leaves and debris fall down to the ground feeding it. And garbage area, it's breakdown of nutrients. So it's going to give false readings of what is actually there. Here's your 20 plots you want to take. Well, it doesn't look like it was like 16, but I think it was 20 per hectare. And it's got to be in a zigzag form. Like that. That's how to take it. Single random sampling. Well, it's good, but it can be inaccurate because who knows if a cow always comes here and pees in that one area, or birds or something like that. Actually, birds, they don't pee. It comes out with that poo. It's uric acid. But yeah, that's why that's not, by taking one sample is not accurate. Stratified random sampling. It's a bit better because you've at least divided it into areas. You can compare different plots with each other. And then the types of soil sampling. So grid sampling, grid cell, or grid point. So 3 ways you can do it. And here it is. So that's your plot. So you can go sample each cell, or you can go sample the points, or you can do your stratified random, or the rectangular grid. But the zigzag is the one I do. Zone sampling. Now, what's zone sampling? It involves dividing the fields into zones that are uniform and can be managed. The success of zone sampling relies on the amount and quality of the data. Here's an example why you want to break it up, because the different runoff areas, this will be different to this, because this will have had all its nitrate leached out, and this might have collected it, as an example. Hybrid sampling. Oh, wow. Hybrid cell sampling or hybrid point sampling. The goal is to capture the most variability in the least number of samples when you're doing soil sampling. The field is divided into zones with similar productivity, then each zone is sampled using a traditional cell-based approach. Sounds pretty similar, but I'm not going to go through all that. But there's the advantages and disadvantages of the different cell, point, and zone to the standard method procedures. They'll have small different advantages. But see, here's the zigzag one. That's the one I reckon to go. It gives a more uniform approach. 20 samples per hectare and 2.2 hectares per acre. So for those in the States, it's 10 samples per acre. So it makes it a bit easier, doesn't it? So you zigzag it up, or you can make it into 2 acre samples for 20 samples. These are the tools you need. only a spade and a little auger, little round tool. It's hollow at the end, and it's got it's open at one side. So when you push it down and twist it, all of the core fills up, and then you lift it out, and you got the core sample. I haven't looked at this for a while. You see, it would have been easier. There's the core sample. There's the little tools. Soil sampling. I don't want to go into that much detail. I like the zigzag method. The depth of soil samples is very important though, because you want to work out what you're planting. So that's going to be the depth in which you're sampling. There's no point in going down and sampling 60 or 90 feet, 2 to 3 feet, 60 or 90 centimeters, if you're only doing cereal crops or herb crops, grasses, because they're only within the first few inches of the soil, a few centimeters of the soil. So you've got to know what you're putting through. This is if you don't have a coring tool, you can do a V. Excuse me. So you take a V, then you take half the slice of the V, and then you've got to divide that up. Come on, where's the dividing thing? You're going to put it on a bit of paper and divide it into 4 quadrants. Oh, here we go. Soil sampling. So get your bit of paper, dry it, crush it, sieve it, weigh it, and look at it. Drying it. You can air dry it. It's probably easier if your humidity is in the range. If it's above 60%, if you're in the tropics, you might want to put it in the oven on low for a low time, 2 minutes. Because you're not taking much of a sample. Remember, you're not getting piled buckets of dirt. You're only getting little tiny bits. Sieving. So the sieve is 6 mil. First, moist samples before drying, you can make it pass through a 6 mil sieve by rubbing with your fingers. Soil in the proper moisture, after it's dried, can be passed through a 2 mil sieve. So there you go, you've got it, you've done that. Mix it, store it. No, we're only doing the divide test. So it goes into 4. That's how you divide it, halve it again. You keep 1. So the other 3 go. The reason why you do that is because that's giving a good, after this is mixed around, it's mixing up the soil, so you're getting a pretty good example of what's in there. Quartering, there you go. That's ready to go for testing. Soil analysis procedures. Don't really have to go through these. A lot of these are labs based because we don't have the kit. You can use aquarium. Some aquarium ones test for nitrate, but they also test for nitrite. So you've got to know the difference. Oh, look, there you go. Concepts covered. Must be what's coming up. Determine the soil pH. Determinant of your electrical conductivity, the organic matter, available N, P and K. Remember there's a difference between total and available, because total means what's in the substrate. Available means what is nitrate and what is ammonium, what the plants need. So who wants to know the amount of nitrite in the substrate, or nitric oxide or something like that, which goes into the total nitrogen. So you always want to know the available, what the plant has access to. Determination of the soil pH. You just go grab, where's the ratio samples? Take 20 grams of soil to 100 ml beaker, and then add 40 mils of 0 ppm water, distilled water. because the distilled water should, if you want to test it before, it should be neutral. And then after you take that, because the soil to water ratio is 1:2. So that's why 20 grams of soil, 40 mils of water. And suspension stirred at regular intervals. This is pretty important, by the way. And how to test it, the best way, go through it. Determine the pH by immersing electrodes into the suspension. If you haven't got electrodes, because you should be calibrating your pH meter often, and to do it properly, you just have to stick it in the pH 4 and pH, what's the other one? Is it 7 or 8? And put it as that with those little sampling bags they give you. Or, which I really enjoy better, is because those sampling bags go off, they only last a few months, and you've got to buy more. You can afford all this ongoing cost. So what I reckon better is the little tiny strips, pH strips, and get ones that identify in the regions that you're interested in. For instance, the 6 to 7 range, you want a lot of different colors, or even 5.5 to 7, heaps of different colors. You don't want them to be green, off green, green, yellow, green something, because you don't know, well, I don't know what it is. So I went and sourced ones, and a good one for that is a saliva and urine pH kit. There you go. That covers all that stuff, isn't it? Look at that. Beer, pH 4, battery acid 1, soap is 9, caustic soda, bicarb soda, highly alkaline. Determination of the EC, where you can build a Wheatstone circuit if you want, or just use an EC meter. Procedure is the same with the 1:2 ratio, and just use your EC meter. And interpretation, EC in decisiemens, so it's above 4.0 decisiemens per meter, it's saline soil, and if it's below 4 decisiemens per cubic or per meter, it's non-saline. You know, that's the amount of salts built up. You can't grow anything in saline, or you can, is it halophytes? But yeah, but pretty much not much grows, because determination of soil organic matter. This is, it's another hard test that I don't do, because I don't have the equipment. So you've got to add all these different chemicals: potassium, chromic oxide, hydrogen sulfide, and let the reaction happen. And I use Munsell's soil chart for my test of soil organic matter. Actually, let's bring up a Munsell soil chart. Actually, I should wait and see. I'll stop. Looks like there's someone else here's rocked up. Okay, sounds like I'm just waking up. Hope you're all doing well. Thank you. Cheers, Raptor. G'day, mate. Strips or drops are great backwards for pH pens. Yes, strips. Must have said it before I did. Great. But yeah, they're rad. They're reliable. You can, and they don't expire. You don't have to store them, or you do have to store them in a proper way. But you know, I've had quite a few pH meters, and I've wasted hundreds of dollars on it. So I haven't wasted $100 on the strips because I still use them. So back to sharing. So that's what I was going to do. Munsell's color chart. Here we go. Munsell's. I shouldn't do it. No, this will do. This goes through the 3 different. There's 3 different ways to do it. If you want to get really, really technical, there's the hue, and what's the other things? I want to explain this. I'll just explain how to do it instead of the technical way. It's the color ratio. So when your substrate's dry, is it dark? meaning it's got a lot of organic matter, or is it light, meaning it's got none? So that's what this comes down to. So I'll leave that in the description below for those folk who want to get really technical. They can go through and do it, or I just like using the darkness. The darker the better. And that's, remember, it's got to be dry, because as you put moisture to most things, they go darker. We're up to, that's right, so that's taking care of the organic matter. Determine the plant available nitrogen is a similar test. All these tests are reactive tests where you put reagents in, like alkaline potassium permangate, and you do this technique. So I was trying to source a mobile test kit so we could all do this. They're too expensive. I just hit a brick wall, basically. Determine if plant available nitrogen. See, here's the test you got to do. Look at that. Okay, yeah, too easy. Pigs. Procedure again. There's a procedure if you really want to get into it. I'm not going to mention it on any of these interpretations. So measuring kilos per hectare. Determination of available P, phosphorus in the soil. So it's Olsen's method. And you look up at Olsen's, buy an Olsen's kit, and they're not cheap. You get like 100 kits for quite a few $100s. So I was going to look at a kit for everything, the available NPK, pH, and organic matter. They're the reagents you need for the soil. P, or you can use a titration meter, or potassium. You need a flame photometer. There's that. And there's the procedure. So it's not easy. Or you can go and buy a, what are those rad? I love one. What are they called? Little meter, come on. X-ray analysis. X-ray analysis meter. Yeah, it costs about $20,000. So that's why I don't really talk about it. But you pull the trigger and it tells you everything. It's a job in itself. You can go to a farmer's field and pull a trigger and go, all right, you need this, you need that. Next. And the determination of available iron, copper, zinc, and manganese is the same thing. It's all with reagents. Unfortunately, because it would be good to know this stuff, wouldn't it? Well, I reckon it would. And then if you've got the same test kit that I was looking at, you can do plant tissue tests with the same. So it's pretty cool. What's that? AAS, atomic absorption spectrometry. It'll do everything. Determine the boron in the soil. See, this course does go into everything. You need a spectrophotometer. Working out the cation exchange capacity is similar again. It's to do with potassium, I think you load it up with. It's a little bit of an easier method, but still using all these chemicals and doing different procedures. Calibration, interpretation, soil test values, levels of soil fertility. What's it? Y-axis profitability of profitable increases. Oh. Just how to plot your results. Soil test interpretation categories. Calibration, interpretation. What's this? Fertilizer, nutrient applied. That's why it's always good to write down your stuff, because you don't know what's happening. crop, or is it something else? Critical limits of available potassium in soils for different crops. So the critical limit, oh yeah, that's pretty good. So you know your max and your minimum, stay within. Indicator plants even, you can use. Certain plants are susceptible to deficiencies of a specific plant nutrient, and they produce particular symptoms which are different from other deficiency symptoms. Thus, the deficiency of an element can easily be detected. So this, if you're going to take home anything, it's probably this one page or this one chart. Try and get rid of Chakraborty. There you go. You take a screenshot of that and you put that on your wall. And if you're commonly getting, well, I know pink DB is it's potassium. Is a potassium pig. So I could go and put potatoes out, and potato would show potassium deficiency, and I know that is you know what I'm getting at. If it shows deficiency first, that means that it's just started to be deficient in the substrate. So that's what this is showing. Pretty cool. And it doesn't hurt to have most of these things because you can probably nearly eat them or use them as green manure. That's it. That's it for today. Cheers, everybody. 42 minutes been going for. Please put your stuff into questions or any discussion, anything in chat, because the show might be finishing soon, because I don't know what to say. It's been, I think that was pretty good. And, well, next week, while there is still people here, because it wasn't anywhere at the start, I was going to choose which ones of here, of these 12 classes, should I be doing. Like I did first week 1, I did that, importance of soil nutrient management. Done week 2 with nitrogen. I was going to do week 3 today, the soil P and K for plant nutrition, but I didn't know. So it's a bit boring for me, those elements. So that's why I went into the fertility and testing of substrates. And next week is substrate health and quality problems, land capability classifications. And the one I'll be excited in is organic manures and the fate of NPK fertilizers. Yeah, that'll be fun, real fun for me. Then there's any other bios. So yeah, I didn't know which way to start. I was going to ask for your suggestion. So do you think next week I should start here if there's no questions? Because it seems like there's not many people watching anymore, but I don't really care. That's their opinion. Or, sorry, that means that they're up to date or something like that. So that's good. But what do you think? Should I do soil, potassium and phosphorus for plant nutrition, or should I do substrate health and quality? What do you reckon? I hope someone put something in the chat. All right, I'll give it 60 seconds. 60 seconds, 55 more seconds. Otherwise, I'll just choose what I want. Raptor reckons phosphorus. Oh, really? You reckon start at week 3? Far out. Okay. Well, that's a surprise. Because it is pretty important to know those elements, because they show the cross reference of the elements. You know, Mulder's soil, Mulder, M-O-L-D-E. No, it's Mulder, M-U-L-D-E-R. M-O-L. Mulder's antagonistic and tag on N-T-A-N-N-I chart. There it is. This one. Where's a good one? So I have to put it in the link in chat because it's pretty cool. And by knowing your elements, I'll share the screen now. Make sure it's going to come up on the right thing. There it is. I got it. By knowing the elements, you can work this out. This. And it shows which ones decrease and which ones increase. It's extreme. There you go. So like calcium. How does it react with manganese? Well, it antagonizes it. Or how does it react with phosphorus? It actually goes both ways. So it stimulates it as well. So it could be an asset. So it's good to know how elements react with each other for different purposes. So, all right, next week I'll start with phosphorus. Done. Week 3, phosphorus. Good stuff. Thanks for your input. And thanks everyone for listening. There's no questions coming through, so I reckon you just want to go and do your stuff. And we can wait till next week until phosphorus and potassium. Yeah, phosphorus and potassium. Why, how to use it, and the ins and outs about it. Thank you, everybody. My Raptor says, very integral, look forward to it. Yes, thanks, mate. Thanks for your nice words. Yeah, well, that's about it. Thank you for listening. Hope you have a lovely evening or day. And I hope to see you next week. Same time next week, but 45 minutes earlier than right now. And happy breeding, happy growing, good health to you all. Bye-bye. Stream.